So we are now being recorded, and I will email the recording link to the section professors in case people want to hear it again, or for those who are unable to attend live. We understand that happens. Can't require people to attend live. We have multiple sections. We have people all over the country. In fact, we have some international students on occasion. So anyway, welcome. Let me start by saying I think this is the most enjoyable course in the program. Certainly it is from my perspective. I'm one of the ones that many of you know helped design the entire MSDA program 4 years ago. We started with 14 students. We now have, well, 4.5 years ago, we now have about 350. And for me, this is the most fun course to teach. We get into doing the, I guess you could say, the heavy lifting of analytics. Predictive modeling is the hottest thing going. Right now, of course, you know, everybody's got dashboards and they're able to say, here's what has happened. What they're really interested in is saying what is likely to happen next so they can leverage that. And that's, again, part of the job of the data scientist, to figure that out, be able to explain that, be able to make some recommendations. So without further ado, let me go into my slides, because I'm just going to, I got to share my screen first. Share my screen. All right, and now you should see my slides. Let me drag some of this stuff out of the way here. Data640, as I said, I think it's the most interesting and fun course I have to teach. I helped design it. I'm in charge of it. We have 3 sections of Data640 with good instructors going this time, so it should be exciting times. The purpose of this overview is just to make sure everybody's on the same page. We don't want to get people off to a start where they bog down administratively getting things going, because there's plenty of work to be done in terms of the assignments, but we want to make sure all the administrative hurdles are covered. So let's start with that. A little pat on the back for some of our students. Some of you have heard, I'm sure, that we had 2 student teams enter into the IBM Worldwide Watson Analytics Global Competition for the 2nd year. The first year we entered, one of our 2 teams finished 2nd. This year we entered 2 teams, all volunteers, getting no credit, putting in quite a few hours per week building the applications. Our 2 teams finished 1st and 3rd, which is pretty impressive, out of over 220 entries. So, you know, we're doing something right. We've also had students win other awards that you see on the chart. The International Monetary Fund Hackathon. You know, hackathons are where they give you a problem and say go, and predictive analytics is a problem. We've gotten recognition from the National University Technology Network. We've also had some people do well in some Kaggle competitions. Again, all voluntary. And this is the point in the program when you get to Data640 where you're starting to build predictive models. This is the point where you might want to think about doing that. If you'd like to put together a little team or individually enter into any of the Kaggle competitions, go to Kaggle.com. They're right there. They just put out a nice beginner's guide to using Kaggle, competing in Kaggle. And so if you want to do that, it's certainly, I would take it as a pretty bold step, and I think it's a good test of your mettle. Yeah, if you don't win, fine. There's no harm done. If you do win, sometimes the prizes are pretty nice. So we've had some good success stories, which means we're doing something right, which is good. All right, well, enough about that. Let's move on to the agenda. Again, I always like to have an agenda. Some of you know I'm very structured. 20 years in the Air Force taught me to try to stay focused on what I'm doing, and I think it's important. But, you know, just briefly, again, we'll outline the course and the program and get started. Okay, as always, it's nice to see bios of students in the classroom. Nice to know some of you probably already in the world of analytics, others making career change, and that's fine. We can handle both types of people. In fact, it's kind of interesting to have a mix like that. So we like to see some bios, what you're doing now and what your interests are. And of course, the most important thing is make sure your email address is accurate so that when we need to correspond with you via email, we've got the right address in the data set. All right, let me harken back. You know, I started mentioning this TDWI. That stands for the Data Warehouse Institute, one of the giant businesses in the analytics world. Research report from January 2015, and that's because they said all of these things, predictive analytics, geospatial analytics, text analytics, in-stream analytics, poised to double over the next 3 years? Well, we're in the next 3 years, aren't we? This is 2018. I think that has happened. I still think the reasons we're not quite there yet are the same ones that were there in 2015. Skills is the top challenge. We need to have people who can not only understand the techniques, especially when it comes to predictive analytics, including deep learning and cognitive computing and things like that, need to be able to explain what you've done. I saw the question. I don't think we can do very much. We don't do anything in this course in geospatial analytics. I have had students use some of that in the Data640 capstone, which I teach also. We can talk more about that offline. As you can see, I think the challenges are still there, and that is you got to have the skills, got to know what you're doing, but you also have to have the aspect that says you can explain it. The so what aspect, as I've called it for many years. The math is easy now because the calculations are done by the software. You will find that the software we use in this course, primarily SAS Enterprise Miner, is phenomenal at doing the calculations. So that part's become trivial. What hasn't become trivial is being able to explain to the decision makers, who by and large are not analysts, what you did, why you did it, how you did it, why it's important, what the limitations are, and what they should do differently in their organization. In other words, applying it to the business sense, the business case, the so what aspect. We'll talk more about that later. Okay, but let's go on and dig down now into a little more detail about what's in this course. As I said, this is a focus on advanced predictive analytics. You started on this little bit of predictive analytics in 630 with decision trees and maybe a little bit of neural networks. We've got other ones here. And when you get done with this, you'll have a sort of a full weapons arsenal of predictive analytics techniques that you understand, that you've tried and used and somewhat mastered. Of course, mastery is something that takes time, but you will be able to do a pretty good job of that. So the major themes that we cover: classification models, certainly. Numerical models, certainly. You know, they're similar kinds of models. One is for discrete outcomes and one's for continuous outcomes. Ensemble models, which are probably new for most of you, where we combine models of models. And finally, something we added 2 semesters ago, deep learning. I'm sure almost all of you probably have heard of deep learning, whether it's some of the things being done by DeepMind, where, you know, they've trained a system to beat the world's best chess players, the world's best Go players, play every Atari game better than any humans ever played it, which are all fun applications, but they've also done some serious things, like, you know, being able to recognize images, being able to interpret natural language. So we can say more about that as the course progresses and we get to that. We'll be using SAS Enterprise Miner software. It's a very powerful, full-featured commercial program. It is used in the cloud, and it's free for our use, academic use. We'll also be using more Python for the deep learning and other aspects, perhaps, when we get to deep learning. There are a lot of things going on in the world of deep learning, downstream on that. So the focus is on these advanced modeling techniques. Here's some that we cover in depth. You've done some with regression models, but we're going to go a little bit more in depth. We're going to do linear regression and logistic regression, 2 different types, one for continuous numerical models, one for classification discrete models. We're going to do support vector machines, a very unusual technique, but can be very effective. We're going to do 2 different segments of ensemble models. One is bagging, boosting, and random forest, 3 techniques that we all lump together to call ensemble models. There's a different kind of ensemble models, that I call heterogeneous models, where we take really any kind of model you want. You could have a neural network, a decision tree, or regression model, and put them all together into a heterogeneous model. Show you how that works. And then deep learning models, we look at convolutional neural nets in a little more depth. But we also look at recurrent neural nets and long short-term memory. And there are many others. Can't cover everything, but we want you to have a mastery of at least these coming out of this course, so you can add those to your portfolio of techniques. There's a couple other things we cover tangentially. We don't have assignments on them, but I think they're very important. I think it's important that everyone at least have an acquaintance with evolutionary models, genetic algorithms. They are making quite an inroad in being able to evolve answers to complex problems. Evolve answers to complex problems, i.e. using genetics. And so I've got a lecture on that will enlighten you and perhaps interest you. And we also want to say just a little bit about cognitive computing. You'll be doing more of that when you get into Data 650. You know, cognitive computing's become hot also. The idea of using chatbots, combining it with AI and neural nets and rules so that you have these, well, most of us go to websites now where the little corner down the corner, there's some sort of a character that wants to talk to us. Sometimes it's a human, sometimes it's not. Sometimes it's a combination of human and a chatbot. But they have become widespread quickly, and they're in the era of what we call cognitive computing. So you'll get more on these later. Okay, so let's see what we got here. Now, as with all courses, this is still a competency-based course. Our entire program was designed to be competency-based. If you've been keeping all of your competency-based assignments in your portfolio, this semester you'll add quite a few more to that. And the nice thing about that is when you go for a job interview or a promotion, you can show evidence of things you've done, not just things you know. You have to know things to do things, but it's more important to be able to do things. And so we designed our program from the ground up to be competency-based. So there are no tests per se. There are no article critiques. There are no case studies. There are things you have to do, projects. What this means is you have graded assignments that are based on what you can do. Assignments are fewer in number because you have to have time between assignments to digest the material, to practice on the software, to put things in order, and to create the rather complex assignments. The weeks between assignments usually almost always have activities designed to help you get to the point where you're going to be comfortable doing the graded assignments. So there are a lot of opportunities to learn the software, a lot of opportunities for discussion, interaction, etc. Works out pretty well. Here is a short list of the actual graded assignments, and there's one key aspect of this you'll probably notice pretty quickly, but let me run through them. Regression assignments, or regression models rather, that assignment is due week 4. It will be both a linear and a logistic regression model. Support vector machine models are due week 6. Again, these are each worth 20% of your grade. The ensemble models, the first type, bagging, boosting, random forest, due week 8, again 20%. The second type, the heterogeneous models, week 9, so only 1 week there, worth 20%. The deep learning models, week 12, worth 15%. And finally, there's a 5% grade proportion for discussion items. And that's based on frequency and depth. Now, I hope you notice something very key, and that is your first assignment, your first graded assignment is not due until week 4. You probably said, oh, hot dog, that means I got a whole month of nothing. No, it doesn't. That means you got a whole month of getting ready for that assignment because it takes a while to get up and running, to get comfortable, to get started with a complex program like SAS Enterprise Miner. I say complex. It's not complex once you get comfortable with it. It's new. And with all new programs, there's a fog factor. You know, it rolls in, you say, what the? You get used to the menus, you get used to it. You will notice in the week 1 lesson, which should be available to you in your classroom, there's a walkthrough. I've got outlining some of the screenshots and so forth. There's also links to many demos and walkthroughs of SAS Enterprise Miner. And there are instructions for getting connected, which is not trivial either. One-time deal. Once you're connected, you're fine because this software, like all our software, with maybe the exception of R and a couple other minor ones, runs in the cloud on the SAS servers for free. So, you know, that's an important part. So don't think you have 4 weeks to go at a leisurely pace. You need to put in the 15 to 20 hours per week we expect so that you're comfortable by the time you get to that first assignment. I don't really have a lot of patience for people who get to week 4 and say, you know, I can't get my SAS Enterprise Miner to work. Well, that's something you were supposed to do in week 1. There are some activities you're supposed to do ungraded in weeks 1, 2, 3, so that you're ready when you get to week 4. Okay? So just a warning, because the only people that ever have trouble with the course, in my opinion, are people who can't find the 15 to 20 hours per week. This is a large, very nice, very powerful software program. Takes a little bit of getting used to, but it's great once you get used to it. And I think that's evidenced by when you get to 670, the capstone course, the practicum, where you can use any software you want. About 85% of the students rely on SAS Enterprise Miner. So they're still using it, and of course all software is available to you throughout your program as long as you're in the MSDA program. Okay, now let's drill down a little bit and say, okay, I see I'm going to be doing a lot of assignments. Are they all going to be the same? They're not all the same, but they're similar in the sense that in each case, you are taking a data set and you are building, yes, it includes in between classes. In each case, I saw the question was, is the software available between classes? And the answer is yes. In each case, you are taking data set or data sets, and you are building predictive models, hence the name of the course, and that's what it focuses on. So yes, they're similar in that sense. They're different in that you're using different techniques, and you're comparing and contrasting them on multiple criteria. But for each of those assignments, you're going to be doing some similar tasks. First of all, you're going to describe the problem and select a robust data set. Now, I'll say a little bit more about data sets in a minute. You have to be careful with data sets, but robust has a meaning, and robust means lots of cases, i.e. rows, lots of features, i.e. variables or columns. Second thing you do is sample the data set. And there's a couple of reasons to do that. One reason to sample the data set is it's just too big to fit into the entire thing into memory. Now, SAS can handle a very large data set, so that's usually not a problem, but it would be if you had a data set with hundreds of thousands of rows or cases. You might want to sample it to make it a little more easier to maneuver with. Second reason for sampling, and we'll say more about this in upcoming weeks, is that you might want to say, let me take a 70% sample, build a model, and see how it works, accuracy-wise, etc. Let me go back and take another 70% sample, which would obviously include different cases, and see how well it works. And if it works about as well, you start getting a warm, fuzzy feeling that you got a pretty good model. But if the second data set, which has a different sample, doesn't do as well or is much different than the first results from the first data set, you get a little nervous. You can do cross-fold sampling. We'll say more about that. So there's reasons for sampling. Another reason for sampling would be to try to get a data set that is more equally distributed. Maybe you've got a heavily imbalanced data set, meaning the target is 99% zeros and 1% ones, which would be true of fraudulent transactions, might even be true of churn, etc. Well, a lot of the models require adjustments, let's put it that way. So you'll be doing some of that. But we'll come back to that in the upcoming week lectures. What's the third test? Well, the third test is once you've got your data set in and you've described what you're going to do with it, you look for, you explore it. You know, you did some of that in Data610. You did some of that visually in Data620. I'm sure you did some of that in Data630. You explore the data set. Look for anticipated relationships. Look for anomalies. Look for unanticipated things. Look for errors. Look for mistakes. And that leads us to task 4, where you want to fix those things. You want to cleanse and modify the data. Now, you know, people often say, I don't really need to do that. But yeah, you do. You should always think about, well, you certainly want to remove errors that are blatant. You want to think about what you're going to do with imputing missing values. You don't always impute missing values, but sometimes you do and sometimes you don't. And we'll say more about that upcoming weeks. You might want to transform variables. Sometimes there are techniques which work much better if the variable distributions are normal. So how do you make them normal if they're not normal? You transform them. Now there's a trade-off. When you transform a variable, it becomes more complex, harder to explain. You know, suppose I have a regression equation where one of my variables is age. Well, we all understand age. And then you say, well, I got a better equation. This one uses the logarithm of age. Well, people are going to roll their eyes and say, logarithms? Oh, my gosh, what's a logarithm? So you got to be careful. Task 5, model. There we go. Finally, we're going to build the models. Okay? And you notice it says develop several models. You will see, as you've already seen probably, that the calculations being trivial now means the models are built rather quickly. Once the program is all set up, once the data is cleansed and prepared, boom, model can be built in a heartbeat. Now, one model, yeah, if you were doing it by hand, you'd probably quit. But when you're doing it with software that does the calculations quickly, you should build multiple models. Further, you should build multiple models using multiple techniques. So once you've learned several of these techniques, that's something to consider. Now, once you've got the models, you have to assess them, don't you? And you don't assess them on a single criterion either. There are multiple accuracy measures. We'll cover that next week in detail. And you want to assess the models, I think, based on more than just accuracy. I think you want to look at complexity. You want to look at ease of understanding, ease of implementation. Those are subjective aspects, but they should be included along with consideration of the pure accuracy aspects. And finally, you want to come up with some clear and concise conclusions that relate to that assignment. Here is what I have found in these models means. Here is what I would recommend. Here are some things I could do different. Here are some areas that can be improved on. It's important to have concrete, solid, insightful conclusions and takeaways. So those are the tasks you need to do for each and every assignment, basically. There'll be specific tasks included in the assignment guidance, but they basically will be aligned with what you see here. Now, there are limits on how much, I was going to say paper, but it's not paper anymore, how much digital space you can use to do these assignments. It might be 6 pages, it might be 8 pages, whatever it is in the assignment guidance, but, double space and all. And people say, oh, I need more space, I need more space. No, you don't. You need to be more concise. You need to put the things that support the analysis in the appendix. You need to put the key measures that are insightful and important in the guts. Furthermore, here's an illustration. I know you can't read this, but you can download it from the link at the bottom. Here's an illustration of one page, which covers, I would say, all of the tasks that I just outlined. Now, I am not challenging you to do this. I do not even want you to do this. I'm just presenting it as illustrative. Now, this was a student presentation at a conference, admittedly, but it is one page. You can see there's an abstract which outlines a problem. There's a data disaggregation, data preparation, exploratory analysis, predictive models, and there's several here. I know you don't understand that yet, but once you have a look at SAS, you'll understand that this is 1, 2, 3, half a dozen models. There's a comparison on multiple accuracy figures. There's results. There are references and acknowledgments. One page. Yes, you could read this pretty well if you go get the real link PDF, blow it up a little bit, and take a look. Again, this is not a challenge. I do not want anybody to do this. I just want to mention that when people say, I can't possibly do this assignment in 6 pages, that here's a good example of a very complete assignment done in 1 page, just as an example. Okay. Discussion items. I mentioned there's a small percentage of the grade for discussion items. They are important. We use discussion items in various ways in our program, and I think they help a lot. In other words, if I say one of the discussion items might be, has your organization ever used any regression models? I would expect you to say more than yes or no. I would expect you to say yes, here's how we use them, here's why it worked, here's why it didn't work, here's what we ran into hurdles-wise, here's some interesting things we did that were successful. Here's perhaps some cultural barriers we had to overcome, whatever it is that will contribute to the overall understanding of how hard it is to change corporate culture and move to a more evidence-based decision process, because that's the ultimate goal, isn't it? To use analytics to foster a more evidence-based decision process in the organization, which I think pretty much guarantees better outcomes. Not always, not in every instance, but overall, yes. So discussion items are available every week of the course. They're graded, so be sure to contribute and contribute substantively, because that's part of the grade, not just the fact that you did put something in there. And I know people moan and groan about the discussion items sometimes, but they are useful. If you find an interesting link or you want to comment on some case you read, put it in there. In anecdotes, information, insights, experiences all add up to contribute to the course understanding. And it's very important in this aspect because this is the stuff right at the cusp of what's happening. Predictive analytics is the hottest thing going right now because that's what organizations want to do. They've got their dashboards. They know what has happened. They want to know what is likely to happen next so they can leverage that, whether it's Amazon wanting to sell you more stuff or a bank wanting to prevent fraud, or a phone company wanting to limit churn, etc. Predictive analytics is being heavily used. And again, mostly by the large companies. The SMEs, the small, medium-sized enterprises, are still trying to figure out exactly how to do it. That's because of lack of skills, and that's good news for those of you who are going to finish this program. Okay, we use one program primarily. We use SAS Enterprise Miner. It is not, you don't have to write code. You can, the code's behind the scenes. You can do a lot more with it than if you had to write the code, and it's a lot more understandable. You'll come to appreciate that. So you have both approaches in the MSDA program. You have Python and R, which is code. You have SAS Enterprise Miner, which is more drag and drop. When we get to deep learning, there's both kinds there. SAS Enterprise Miner has been the #1 seller by far on the commercial side, so it's good to expose you to that because you're going to run into it in many cases in the outside world. You can go visit the fact sheet, and again, you'll see more of this. We'll be using it. Now, what do you need to do? Well, first thing to do is start getting connected to the software and using it as soon as possible. The more you play with it, the more you will learn, the more you will value it. The more you play with it, the more you will learn, the more you will value it. There are a lot of YouTube videos out there. Start with this one. They're great. They're really, really well done by the SAS people. They want you to succeed, obviously, with their software so that you'll want to consider buying it when you're out in the real world, or your organization will consider buying it, or may already have it. But anyway, there are some getting started walkthroughs. These are two walkthrough documents. They say, all right, here's a problem. We're going to see if you can duplicate what we've done, step by step, keystroke by keystroke. Okay, one is a PDF version, and one's more of a version you have to look at online. They're about the same. I like the PDF version the best because I can download it and have it offline and open it up in a separate window and so forth. A little bit easier for me, but some of you want to use the other one, that's fine. They're about the same. I said I would say more about data sets. Data sets show up throughout the course because obviously you need data sets to build predictive models. And you need fairly good data sets. However, you can go either way on the data sets. If you get a trivial data set, it's not going to work well. It's not going to have enough cases. It's not going to have enough variables or features. It's not going to be robust enough to give you a good model that you can rely on. If you pick a data set that's overwhelmingly large and complex, my hat will be off to you for taking that challenge on, but in many cases it will overwhelm you. You know, some people say, I'm going to get this data set with 10 million cases, and they'll spend the entire time cleaning it, cleansing it, looking for missing variables. It's just a mess. So the sweet spot is somewhere in between, isn't it? And that's different for each of us. When you are just learning a piece of software, as you are for most of you for SAS Enterprise Miner, and learning a technique, as you are for things like sport vector machines and maybe ensemble models and others, you really don't want to bog down too much on the data set. You'd like to get into the modeling. On the other hand, there is always a bonus, if you will, in terms of the point scoring and the grading of the assignments for people who take on more robust data sets. So there's a trade-off there. So you kind of have to pick and choose. There are links in the course website to many data sets. You need to go look at lots of them. Take a look, see how they stack up. You know, if you can find something with 10, 20,000 cases, that's kind of neat. Maybe 15 to 30 variables, that's kind of neat. You know, those would be kind of nice. Sometimes that's easily available. Sometimes those are a little harder to find, but they're out there. If you want to take on something with a couple 100,000 cases and 150 variables, it's going to take a little more time. But it's worth more point-wise if you do more with larger data sets. So that's a trade-off. Be very honest about that. So I say if you're new to the technique and new to the software, don't pick a data set that's going to suck up all your time with cleansing and preparing the data set, because the model building is the most important aspect. We have 3 sections going this semester, so it's busy. I have one, and we have 2 other instructors with the other 2 data sections. We're all teaching the same material. We're all using the same videos and lecture material. And so it's all right the same. Assignments are the same, and everything's the same. We're all well-versed in the techniques. We have one teaching assistant who is outstanding. John Cook, a graduate of our program, is our outstanding TA. He will help you with all things technical, and of course the faculty will weigh in also. And John is our resident expert on the deep learning assignment when we get to that. So we do rely on our TA to help us with there. Okay, each week the lesson will appear. The weekly lesson guidance will appear. In fact, week 1 is already out there, at least in my section, and should be out in the other sections if not already there. And week 1 has an outline of the topic. It has 2 or 3 required readings. It has a lecture, video lecture, either a walkthrough or a lecture, content lecture on the material. You want to look at those because they're very, very important. That's the content for the week. That's what you need to know. Okay. I also like to supply many, many, many extra links, videos, readings, etc., for people who want more. You know, this is what's interesting about this course is something new happens virtually every day. When I see something just so interesting, I think you got to know about it. I will post it in the announcement section and send it to the other 2 professors because it's really important that you keep up. There could be a new breakthrough at any moment on some new technique or some new way of using it or some application. You'd be surprised. And looking at applications, fielded real-world applications is very important to solidify the grasp and the understanding of how important these techniques are. So check the announcements section often. I realize that we are all fighting for your time and energy because you got other things to do. Most of you are working, you have families, you have other obligations. I want to make it so enticing by putting interesting things in the announcement section that you will want to at least spend a few minutes checking that section to see what's there virtually every day. Course assignments, of course, we grade based on the policy of the graduate school, and that says that on time, on-task work is a solid B. In other words, assignments that meet the minimum requirements, they're well written, they're complete, they don't have typos, misspelled words, they're properly referenced, they cover each task adequately, they get a B. Don't think that that is A work, that is B work, which is fine. You get all Bs, guess what you get at the end of the 2 years? A graduate degree. If you want to increase your chances, but not guarantee, of getting a higher grade, you have to find ways to add what I call evidence of critical thinking to your assignments. Now, what does that mean? Well, maybe if the assignment is to build a regression model, you build 2 or 5 or 10 regression models, varying some of the parameters, varying some of the inputs, varying the samples, and you compare all those, and you come up with some insightful insights and conclusions. It takes more work, doesn't it? But that's why you might increase your chances of getting a higher grade if you do it well. So there's ways to add critical thinking in almost every assignment, but it takes more effort, and that's why those people who do it well are going to get higher grades. But that's not to worry. The B is a solid grade, and it's the norm. And if you put in the 15 to 20 hours per week, you should be able to get the B grade. Again, the only people who've had trouble with this or any other course in the MSD program, people who just can't find the time. And that's a critical success factor. You've got to find the time and put the effort in. By the way, I should mention that when those weekly lesson guidance documents occur each week, mine usually I put in Sunday or even Saturday sometimes. They come up, they appear. Take a look at that and see what it is you're expected to do that week. It doesn't mean you have to do all the work that day, but you need to look and say, oh, I see what I've got to do this week. I've got a lot of stuff to do. And so you allocate your time during the week so that you have the time to put in. All faculty strive to be as fair and as objective as possible. I know that sounds very common to say, and it is, but want to make sure that if you don't think we've graded you fairly on some assignment, you are free to push back on that. If we missed something or misunderstood something, we'll certainly take another look at it. I provide feedback via audio. I take a look at your paper, I go through it page by page, and I record comments, both on content and substance. And I use a package called Pure Voice video files. They're very nice, so that way you get a lot more feedback than if I were to write a few notes. Miscellaneous. Okay, so I said the lesson guidance comes out by midnight Sunday because the week technically starts Monday morning. Mine often is up earlier because I know people want to do some work on the weekends. It's an overview of the week's lesson. There'll be lecture material included via video or recorded video demo lecture, which it may be a walkthrough, it may be content material. There'll be many software walkthroughs available. I've got over 90 videos out there related to SAS that I've created. They'll all show up one way or another. If we need to have online office hours via WebEx, we can do that. If people want to get on and discuss a certain aspect, we can arrange that. We have discussions area for content discussions. We also have a discussions area for questions. There's a special one called Let Me Have Any Questions. And if you have a question where you think the answer would be useful for all to see, that's a good place to put it. If your question just pertains to you, you might want to go email to the professor, or if it's an emergency, a phone call. So what do? Well, you open that lesson guidance up each week. You say, I see what I have to do this week. I see the readings I have to do. I see the lecture I have to watch. I see whatever the activity is. Remember, there's activity in between the weeks that aren't assignments, and you make sure you stay with it, because you're getting 6 credits, 6 graduate credits in 12 weeks. There is no slack. And of course, we also have Thanksgiving packaged in there during this semester, and we don't take off for that. We still continue to march, so you've got to sort of plan your semester out as well as you can. Do not, again, let those first 3 or 4 weeks slip by without becoming pretty well versed in how SAS Enterprise Minor works, especially being able to get into it and try that practice walkthrough problem, step by step. If you don't get what they got, we need to figure out why. Ask questions. Read the announcements often. Every day would be ideal, and there's that I mentioned, if you have any questions area. So what are you going to do in week 1? Well, you're going to hopefully jump right out there and make sure you can get connected to SAS Enterprise Minor. There's a couple of quirky things there that you will not like. And one of them is you have to have a particular version of Java running in order to access SAS. I don't know why. I can't answer the question why they aren't able to accommodate whatever version we have, but the instructions are clear. Follow those instructions, you will get connected to SAS Enterprise Minor. Once you are connected, you want to make sure you don't update your Java application during the semester or while you're using it, because it will undo that. It's a quirk. I don't like it. I wish there were an easier way, but there isn't. You may have noticed a couple of emails from John Cook mentioning that, or postings in the classroom, mentioning the fact that although SAS E Minor says it only runs on Windows, there have been people with Macs who have found a way to make it run on a Mac. So if you're a Mac user, pay attention to what John has posted and check with John about getting connected to a Mac, connecting a Mac to SAS Enterprise Minor. Then you want to explore the SEMA methodology. Now in week 1, there's a lecture, video lecture recording that walks you through what the SEMA screens look like and what the SEMA screens are for. And that will be important that you understand that acronym and all the many ramifications of it, because that's what is used within the program. So you want to get comfortable with the software. Every time you get a new piece of software, as I said, there is a fog factor. That will lift as you play with the software. You will grow from being confused to being very comfortable with SAS Enterprise Minor, and in fact, by the end of the semester, I would consider you even a very close to a power user. That does not mean that this is a course designed to get you certified as a SAS programmer or a SAS Enterprise Minor user. It's not. We are using SAS as the software to do the very important job of building advanced predictive models. Advanced predictive models. Okay? My last slide. There are no books required to be purchased for this course. However, if you have a few extra bucks, this would be an outstanding book to buy. This is not a textbook. This is light and easy reading. The gentleman who got me started in the world of analytics is Eric Siegel, i.e. the author of this book. Eric is another one of the giants in the world of analytics, along with Tom Davenport, along with many others. Eric runs the Predictive Analytics World Conferences. I've been to 2 and presented at 2. They're great. Eric also is one of the editors of PA Times, Predictive Analytics Times, which you should sign up for free. It doesn't cost a thing. Eric's book is a bestseller. This is version 2. It's soft paperback. It's probably $15. It comes with a complete set of MP3 files that you can listen to. You can listen to him read you the book, and he's very entertaining, by the way. He's not a dull reader. He's an entertaining guy. He's a great speaker. But anyway, look at some of the little pieces that are pulled out of the book. You read this book, you will have such a good understanding of why predictive analytics is so important. Why predictive analytics is so important. You'll also understand some of the quirks. You'll understand that even the big guys make mistakes with predictive analytics in terms of interpretation. And none of it in technical jargon at all. Very, very, very entertaining. Very, very, very insightful. So I give it 5 stars, or however many stars you're allowed to give. You will notice that the bottom line, 182 examples from Airbnb, the BBC, Citibank, Crowning, Facebook, etc., 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 etc. Examples of companies that are using predictive analytics effectively. And I mean in plain English what the ROIs are. So if you've got a company where they don't think predictive analytics is good to go, you can hit them with those 182 examples in some detail. It's a beautiful part of the book. But he also has some horror stories in there of how people misused it. So, the subtitle, of course, is How to Predict Who Will Click, Buy, Lie, or Die. But it is a great book. So I'm just pointing that out. You don't have to buy it, of course. It has nothing to do with the course. But what a background it is to give you. Okay, let me go back to my website. I'm going to stop sharing my screen. And I'm going to open it up in case there are any questions. And again, mostly questions about the administrative side. Your content questions will come as you begin to get into content. But I want to make sure everybody's on the same page administratively. Your main task is to get connected to SAS Enterprise Miner and start walking and wading around in there. By the way, I should mention the help screens I think are very useful. And you'll see there's 2 videos for this week to walk. One's an overview of analytics and one's an overview of SAS Sema. So those will give you a good feel. So let's see. Do you mention if there will be a group assignment? There are no group assignments in this course. Most courses have 1 or so group assignments. This course does not. That was an easy question. I should also, again, remind you that all the software you use in this program is available to you throughout the program. I think it's a measure of the utility of SAS Enterprise Miner that about 80% of the students in the capstone course, which I also teach, are still using it. They can use whatever software they want. Some use Python and R and Hadoop. They use whatever they need to use to do their projects. But SAS still is very prominently used in that course, so it must work pretty well. It will give you some head scratching at their first, but you'll catch on pretty quick. And we have lots of walkthroughs and tutorials, and we create more if we need them. Okay, well, I am delighted that we have 3 sections and 3 great professors, 2 great professors and me teaching this off. So this is fun stuff for me. I really think it's the cusp of what's hot in the world of analytics, and when you get through this course, you're going to have a really good feel for how to build predictive analytics models, how to interpret analytics models, how to correctly judge the utility of analytics models. Just because a model is accurate doesn't mean it's useful. Remember, Netflix gave a $1 million prize to a group of people who built a predictive analytics model that improved their algorithm for recommending movies by 10%. That was the challenge. These people did it. They got the $1 million. Netflix never used that program. It was too complex, too cumbersome, and so they never implemented it. But they paid the $1 million. They held true. And you saw that we've had some students win some Kaggle competitions. So, people are doing things with this stuff, which I think is great. All right, well, remember, this meeting is recorded, or this presentation is recorded. I will send it to the other professors. They will post it in the classroom, as will I. You can go look at it again if you'd like. But this is the contract between you and I, what you're expected to do, what we're expected to do as faculty. We will make sure you're not confused, befuddled, and so forth, you will make sure you do the assignments and understand the techniques and learn. This is a fun thing. You got to learn. You know, you want to add these techniques to your arsenal so that people say, do you know what a support vector machine model is? Oh, yes, let me explain when that should be used. And by the way, the reason we have so many different types of models is because no one model always works best. Furthermore, it's almost impossible to predict in advance which of the model techniques would work best for a particular problem. So the bottom line becomes clear, doesn't it? When you have great software that does the heavy lifting of the calculations for you, why not build all the models? And why not build multiple versions of all the models? What we call parametric optimization. Every one of these models, whether it's regression, support vector machines, ensembles, deep learning, etc., has multiple parameters that can be tweaked. Since the software goes, boom, I'm done, boom, I'm done, boom, I'm done, once you set it up right, why not tweak multiple parameters, run multiple excursions, and then grade all of those models on the appropriate criteria? Seems like a simple answer to me, but it is tough until you learn all these models and become comfortable with them. So that's where we're headed. You'll be there by the end of the semester. Okay, thanks. I don't see any more questions, so I'm going to go ahead and stop the recording.